Good evening, all. Ms. Sahasra, are you there?
Yes, ma'am.
Okay. So, good evening, everybody. Today is the last day of this workshop on applications of signal processing using MATLAB. So, we will start the session now. So, please introduce the Sir Sahasra.
Yes, ma'am. Yeah, good evening, everyone. And it's my privilege to introduce today's resource person, Mr. T. Arivagan, and a dynamic project engineer with over 3 years of experience in image processing, artificial intelligence, and also machine learning, with strong expertise in Python, deep learning, computer vision, NLP, and also generative AI. He has consistently worked on real time research and development projects. He has also conducted more than 20 workshops and seminars across reputed engineering colleges, empowering students with practical knowledge in AI and emerging technologies. His blend of technical depth and hands on teaching makes him a true mentor in today's rapidly evolving tech landscape. It's my privilege to invite you, sir. And, sir, the session is all yours.
Okay, thank you. Thank you so much. Okay, good evening to all. Myself, T. Arivalagan from Pantech Learning. Today we'll discuss about the content based on the signal processing with the applications. Today we'll explain about the final time. I will explain the one application from the medical based on the applications. The application is brain tumor detection and segmentation method. Finally, I will show the coding part and I will show the output also. First, I will complete about the theoretical part. Okay. I think some people know about that what is the image processing, why we are using the image processing, all things. Step by step, I will explain. If you have any doubt, any queries means, last time you can ask the queries. Okay. First, I will go about the theoretical part. Okay, but now I will ask the question, what is the image processing means? All are know about the condition. First, before the image processing, what is the images? Image is nothing but visual representation of pixel. Okay, otherwise collection of the pixel. For example, if we are having one image means we are having some collection of the pixel. It is called as the images. Collection of the pixel means based on the image height and width, we need to call about the images. This is a visual representation of pixel. Maximum image size 250 into 250. Highest size is 500 into 500. We need to mention. It is comes under the images. What is the images? It is collection of visual representation. Okay. After that, for example, what is the one image will be there? How they will convert into the pixel means like this. Okay. If now this is a pixel, we will converting into the one images. Okay. Normally, if you saw the one images, these are images. If you saw about the pixel wave means this is a pixel. Each pixel, if we are using the any RGB image means each pixel we are having the three value will be there: red, green, and blue. That what is the meaning of RGB and all things? Step by step, I will explain. Before we learning about the image processing, we know about the image. Image is nothing but collection of the pixel. Okay, sir, image is nothing but collection of the pixel. Video means collection of the images and the frame. It is called as the video. Okay. Image means collection of the pixel. Video means collection of the images and collection of the frame. Okay. Okay. If we are mostly in the real time, we are using different type of image file format. Mostly we are using JPG, JPEG, BMB, BNG, DAF format, GAF format. Like this, different concept purpose. We are implement the different type of images. Okay. These all are image file format. If now we are using some image means the image they have some type will be there. We are having the three type color images, the RGB images, gray color images, and the black and white images. RGB color image means all people know about the RGB. RGB means red, green, and blue. RGB it is called as primary color. It is three channel value. What is the meaning of three channel value means we are having the red, green, blue. Okay. After the gray color, it is called a single channel value. It means we are having only for the gray color only. That's why they called about a single channel value. I think all are know about RGB is the prime color. What is the secondary color? RGB is called as a prime color. What is the secondary color mean? Cyan, magenta, yellow. It is called a secondary color. Okay. Total image we are having the three types of color format. One is the RGB, gray color, and black and white. Color image means RGB. RGB means red, green, and blue. We are having the three channel value. The RGB value 0 to 255. RGB value 0 to 255. Same like this, gray color value also 0 to 255, but it is single channel value. So what is the meaning of channel means? For example, we are having the RGB image means each pixel we are having 3 value. Red, green, blue. But if we are converting to the gray color, each pixel we are having the one value only will be. That is the main difference between the RGB and gray color for the 3 channel and single channel. After the black and white means only for the black and white color only, the value 0 or 1. These are RGB images. These are gray color images. These are black and white images. Okay. Black and white images, or it will called as binary images. For example, this is the flower will be there. This is the RGB images. The RGB image, each pixel we are having the 3 color concern: red, green, and blue. Based on the pixel wise, they will have the 3 color. Red color also will be there. Green color also will be there. Blue color also will be there. For example, in your home, you need to paint some wall, means you need to go some shop. You want to purchase the paint. That time they will ask some color. Which color you want? You give some manual color. Manual color, if you are giving the color, if you say the color name means they will make the own color. That time they will mix the RGB color only. Okay, na? Based on that only they will make the new color. Same like this, if we are giving the any input images, this format is RGB only. Each pixel they have the 3 color value. For example, red color 0, green 0, blue color 0. This is starting value. After that, based on the each color place, they will change the value also. For example, here red value is 49. Green value is 64, blue value is 66. This comes under the one new color. Same like this, each pixel they are having the different color type of format will be there. It is called as RGB, red, green, and blue. This is a gray color. But I need to say another thing also. Gray is not for the black and white. Black and white is the different. Gray color conversion is different. Okay. It look like RGB only, but it is light color. But gray, black and white means you're converting to the black and white. Only for 2 color only available in the black and white. Black and white. If you are converting to the RGB to gray, this light color only. Okay, na? Compare look like RGB only, but it is light color. If you are converting to the RGB to gray, it is a pixel value. Each pixel we are having only one value will be there. But if we are having the RGB images, each pixel we are having 3 value. Okay, na? It is the value. One channel 0 to 255. They have only for the 8 bits. Okay, na? But in the RGB, each red color 8 bits, blue color 8 bits, green color also 8 bits total. Okay, na? Total 24 bits. These are black and white. I already explained now. RGB is called as primary color, secondary color is CMYK. Normally we'll call CMY, cyan, magenta, yellow. Okay. Now I will go through about the image processing. What is the meaning of image processing? Image processing is nothing but if we are giving the any digital images, they will enhance the images and extract some useful information. It is called as image processing. What is the meaning of image processing? They will enhance the images and extract some useful information. Which type of images? Some digital images. Digital images, they will analyzing and manipulating for digital images, especially for the improve the quality. Specifically for why you need to use the image processing, specifically for the improve the quality. That is the use of image processing. Again, also I will say what is the meaning of image processing means. Image processing is nothing but enhance the images and extract some useful information. Okay. For example, I will show my photo. Before I did not introduce my name. I will show the photo means you did not understand. You don't know about my name. After that, I will say this image means Arivalagan. This image means Pantek e-learning. This image means another name like this. I will say the one by one name. Based on that only, they will identification. This image means this name only. Correct. That purpose, what I need to do, I need to extract some useful information from the images. That purpose only we are using the image processing method. Again, also I will say image processing is nothing but enhance images and extract some useful information from it. Which type of, mostly we are using the digital images. Based on digital images, I need to analyzing and manipulating. Mostly why I need to use image processing, I need to improve the quality. The purpose only we are using the image processing. That is the main thing of image processing method. Next, purpose of image processing. Visualizing purpose we are using. Image sorting and restoration purpose we need to use. Image retrieval purpose I need to use. Image recognition purpose I need to use that. If I am using the image processing means, what is the use? That is the first one is visualization. Second one is image sorting and restoration. What is the meaning of visualization? If I am giving any image means I want to do about the visualization part. Okay. After that, image sorting and restoration. I need to create the better images. If you are giving the black and white, I need to converting into the color images. Like this, I want to do upward. The purpose only we are using the image sharpening and restoration method. Next, image retrieval method I need to use. The next image recognition method also I need to use. There is the main purpose of image processing method. Okay. Now I will explain the content based on the image processing in the MATLAB. The image processing we are using the Python also. But what is the main difference? If we are going with image processing in the Python means we need some library. OpenCV, Pillow library, NumPy library, TensorFlow and Keras. Like this, we need some default Python library will be there. This is an open source library. After you have the Python image processing code, you need to install the library, you need to execute the code. But compare with the Python code, if you are going with image processing with MATLAB means you need to install the toolbooks. The Python means separate, you need to install the library. But if you are using the image processing with MATLAB, you need to install the toolkit only want to install. Which toolkit you want to install? Image processing toolkit you need to install. Okay. So why you need to use that MATLAB? I know about the basics Python. Can I go with Python only now? Why specifically I need to go with MATLAB means if you'll do with any project in the MATLAB for the any BTech level, BTech final project or MTech level project, if you choose the MATLAB project means they will give the first preference for the any interview. Why means, but nowadays most of the people they won't show the intents about the MATLAB. But we know about the MATLAB separately for the signal processing, for the any another method. If you know about that simulation based any method, if you know about the MATLAB, easily you'll find out the job for the MNC or any company. Which means, but nowadays most of the people they will go about the Python, Java, full stack, Python full stack, Java full stack, main stack, React, Django, like this only they are going the next step. But if you are changing about the MATLAB, if you are learn about the MATLAB, you are searching any job, will possible to find easily. Okay. Next, image processing, we are having the two type of image processing. One is the analog image processing, one is the digital image processing. Image processing, totally we are having the two types. One is the analog image processing, another one is the digital image processing. What is the meaning of analog? This look like black and white only. For example, I am going to the one Xerox app, I give you the one printout. Without any changing, they will show the output. It is comes under the analog image processing, the flex, example flex, printing, scanning, and hard copy. It is look like for the analog image processing only. Analog means without any modification, you will get the output. I am giving the whatever I am giving the input, same thing you will get the output. It is comes under the analog image processing. Next, digital image processing. What is the meaning of digital image processing? I am giving the input images. Next, they will apply the pre-processing method. Next, they will apply the image processing techniques. They will show the output. For example, I want to take some passport size photo. I want to take some passport photo. I'm going some photo studio. They will took my photo. After took my photo, they will do some editing process. Correct? This comes under the pre-processing. After they will do some editing. Editing means the contrast value, smoothness purpose, restoration, all things they will do. This comes under the techniques. Finally, they will give you some print option. This comes under the output. Okay. Normal analog image processing, I need to give the input without modification, they will show the output. But digital image processing, if I will give the input, they will apply the pre-processing method, techniques. Which techniques? Digital image processing techniques. Finally, they will show the output. This is the main thing for the image processing. We are having the two type. One is the analog image processing, another one is the digital image processing. Okay. Now we need to discuss about only for the digital image processing method only. Okay, if for example, I am giving on digital image processing, this is the images, I apply the pre-processing method, they will show about this apple, banana, and grape and one by one. Okay. Fundamental is nothing but the techniques. I am saying that techniques. These are all techniques about that image processing method. If you have the notebook means once you noted that techniques. This is very important. First, image acquisition, image enhancement, segmentation method. First, image acquisition is nothing but we need to give the input image. This comes under the image acquisition, image enhancement, segmentation, feature extraction, restoration, retrieval, fusion method, compression, watermarking, cryptography, and steganography. These all are fundamental of image processing method. It will sometimes they will call fundamental, sometimes they will call it about image processing techniques. These all are techniques about the image processing. If you have the notebook means once you note it, image acquisition, image enhancement, segmentation, feature extraction, restoration, retrieval, fusion, compression, watermarking, cryptography, and steganography. These all are fundamental of image processing or fundamental or techniques of image processing types. Next, image acquisition means I need to give the input image or video. I need to give the input, correct? If now I need to give the input some image or video. This is image acquisition. If now in the analog image digital image processing, we are having input, I give an image acquisition. Next, pre-processing method. Pre-processing. What is the meaning of pre-processing? Pre-processing is nothing but they will improve the quality in my input image or video. They will increase the quality of my input image or video. They will increase the quality of my input image or video. That is the use of pre-processing method. What is the use of pre-processing? Pre-processing method, they will increase my image, they will increase the quality of my input image and video. The quality increase purpose, we are having three methods will be there in the pre-process. Quality increase purpose. First one is the resize, second one is the color conversion, third one is the filtering method. Okay. First one is the resize, second one is the color conversion, third one is the filtering. First resize method. What is the meaning of the resize? I am giving one input images. I have the different type of input images. Each images I have different size also. Whatever I am giving one input image in my coding part, I need to convert it into the one particular size. For example, I downloaded one image from the online for any Apple banana images. I am giving the input for the Apple image. After giving the input for the Apple images, these different size will be there, correct? After giving the input, I need to convert it to the one size. If I download from the online, they have a different size. But whenever I am giving the coding part on input images, I need to convert it to the one size. The size is mostly we need to mention 150, 150, otherwise 256 and 256. Starting is 64 into 64, ending is 500 into 500. Okay, whatever size you want, you need to change that. Okay, this is first step of resize method. I am giving the input image, I want to reduce the size. If I am giving the 250 into 256 into 256, it will convert into the 128 into 128. What is the meaning of 256 into 256 means height and width. Okay? This is a resize method. I want to change the input image size. That is the use of resize. Next, color conversion. Color conversion means I need to convert into the color. Color conversion, we are having the three type will be there: RGB, gray color, and black and white. Okay, now color conversion, we have the three types: RGB, gray color, and black and white method. First, I am giving an input image. This is the RGB image only. The RGB images I need to convert into the gray color. Why I want to convert into the gray color? I am giving the input image the RGB image only. Why you need to convert into the RGB to gray? If you are converting means what is the use? For example, if nowadays all are using the mobile unlocking purpose, all are using the face unlock, correct? The face unlock, I need to unlock my mobile. Front of the camera, I will show the face. Input images. When I am buying the new mobile, that time I store my pages in the database. Okay. If I give the input images, they will check the database image also. Both same only mobile will unlock. Correct? The both same or mismatch I need to check. That purpose I need to extract the input image feature and database image feature also. That time if we are having the RGB image means each pixel we are having three values. It is very complicated for the feature extraction purpose. Why means sometime RGB color more will be there, green color more will be there, blue color value more will be there. That's why only I need to converting to the one color to another color. RGB to gray I need to converting. If you are converting to the RGB to gray, okay, if you are converting to the RGB to gray, RGB means each pixel we are having three value will be there. But if you are converting to the gray value, gray color, each pixel we are having one value only will be there. It will easily extract the image feature. The purpose only we are converting to the RGB to gray. For example, not only for the face recognition. But nowadays all are using the Phone Pay or Google Map, sorry, Google Pay. You after purchasing any place, you want to scan the barcode. You think about after scanning with 1 or 2 seconds, they will display about that shop name or owner name. How they will recognizing? They are applying the image processing method also. They will doing resize and color processing method also. They will work. Face recognition, fingerprint. That most of the place they are implement the digital image processing method also. Okay, that is the use of color conversion. Pre-processing, we are having three types: resize, color conversion, and filtering. First one is the resize. I need to converting to the size, one size to another size. I need to change the input image size. After that, color conversion. Color conversion means I need to converting to the color, RGB to gray, I need to converting. Mostly we are won't converting into the black and white. Why I mean the black and white is 0 or 1 only. That's why no need to convert into the black and white. Only want to converting to the RGB to gray only need to convert. Next, filtering method. Filtering means I need to increase the contrast value, smoothness purpose. We are using the filtering. Okay. These all are pre-processing method. I'm giving the input images. I need to apply the pre-processing. Next, I need to go through about the image processing techniques. If now one project we are doing about segmentation means you need to apply segmentation. So restoration means you can go through with restoration like this. Based on the project, you need to apply the one by one techniques method. No need to apply the all techniques method in one project. Based on the project, you can apply the techniques method. Okay. These are color images. Resize the images. Color conversion. This is RGB. It will converting to the gray. Okay. This is gray color images. This is not black and white. This is gray images only. This is the black and white. Just check about the different gray color and image black and white. No need to don't get confusion. Okay. Filtering like this only they will apply the filter for the images. These images I want to increase the contrast value, smoothness value. Original. I need to check the detail. After that, you will get some sort. Okay. But now I apply the first method of image enhancement method. I need to apply that. Okay. Okay, what is the use of the image enhancement method? If you saw the image means you'll get the idea. If I apply the blurry images, they are converting to the good quality images. The purpose only we are using the image enhancement method. I need to use that. Okay. I already explained about the image processing techniques or fundamental of image processing. They are having some method will be there. First, I need to explain about the image enhancement method. I will explain. Okay, what is the meaning of image enhancement? What is the use of image enhancement means? If I are giving the one blurry images, they will converting to the better quality image. That is the use of image enhancement method. Once you check the images, first they are applying the like this image only. After that, they will converting to the some better quality images. The purpose only we are using the image enhancement. What is the use of the image enhancement? They will comes under the we are uploading the blurry images. They will converting to the better quality images. That is the use of image enhancement. Okay, na? They will include for the contrast value, enhancement, spatial filtering, density. Based on that only they will converting to the restoration. Okay, this is the image enhancement method. Next, segmentation method. If nowadays the segmentation method is very important. Why means if nowadays automatic driving car they are developing more. The automatic driving car purpose the segmentation is mandatory. Not only for the automatic car, robotic purpose also the segmentation is mandatory. For example, if now I am driving the car, okay? When I am driving the car, I know about some traffic rules. I know about some traffic sign also. This is the stop. This is a red color means I need to stop. Green color means I need to go. This is for the traffic wall. This is for the human crossing the road. Like this, I know. Why means I'm the human. Before some people teach about that. This for traffic sign. This sign means you need to do about like this. But automatic driving car, how you know one human crossing the road, one dog crossing the road. Here some speed breaker will be there. This place some bath hole will be there. How the automatic driving car know? The purpose only I need to apply segmentation method. Once you check this image, this normal image. After applying segmentation method, system they will understand this is a pedestrian, this is for the car, this is for the bus, this is for the truck, truck, bike, person, dog, like this. Different type of object will be there, their identification. The purpose only we are using the segmentation method. In that image processing and computation purpose, the segmentation is mandatory. Okay, na? How they will read the segmentation means in the computer vision, image segmentation is the process of set of pixel. Inch by inch, they will read the segmentation. If I am giving the normal images, the images they have the person image, dog images, uh, bus images, motorbike images, car images like this. All images will be there. Mean if I apply segmentation method, each image purpose separate they will apply segmentation for understanding purpose. This is the person, this is for the car and bike and motorbike like this. Okay. After applying the segmentation, how the system identification this is a person, this is for the bike and car means they already trained the data. Like this feature will be there, mean this is a person. There is like this edges, like this feature will be there, mean this is a dog, a car, a bike, like this. Based on the feature only, they will get the idea. There is a use of image segmentation method. Okay. Nowadays, image segmentation is mandatory. Why means nowadays they are developing the automatic driving car and robotic. The automatic driving car and robotic purpose, image segmentation is mandatory. Image recognition. Image recognition means this comes under the face recognition. Okay. For example, this is my mobile unlocking purpose. I am using this my input face feature. This is my input face. I will extract the my input face feature. They will check input face feature and database face feature both same only the identification. That is the use of image recognition method. Mostly we are using the face recognition, fingerprint recognition. Why means most of the college before most of the college they are using the fingerprint. Now they are going the upgrade method. They are using the face recognition technique also. That is the use of face image recognition method. Okay, na? The image recognition method they are using from image and video also. Okay. Next, image restoration. Don't get the confusion for the image enhancement and image restoration method. This full and full different. Image enhancement means they are converting to the blurry image to normal image. Image restoration, if you upload the any black and image, they will converting to the color image. That is the use of image restoration. They will restore, they will enhance. Enhancement is different. Restoration is different. Okay. The restoration is nothing but it is recovering. Recovering means I need to I have one background images. I need to converting to the color images. That is the purpose only we are using the image restoration method I am using. Okay. If I upload the background image, they will converting to the one original good quality images for the RGB image. That's why we are using the image restoration method. Next, compression. Image compression. For example, I need to apply some job from the online. The online, I need to mention my name, my date of birth, and Aadhaar card, and all things I mention. Finally, I need to upload my passport size photo. If you are applying any job, means you need to apply the resume. Otherwise, you want to submit some file, means you need to submit. But in the file, only will possible with only for the KP. But you have the images in the MP, means you want to compress the images. You need to compress the images, but without damage, they want to compress the images. That is the main thing. For example, on job purpose, I need to apply from the online. The online, I need to upload my passport size photo. But in my passport size photo, I have for the MP format. I will compress to the MP to KP. They will they will did not show the better quality. They will decrease my quality also, correct? That's why only we are using the image compression method. If you are using the image compression method means they will not discrete your quality. Better quality, same whatever you will displaying about the 7MP quality, the same will showing about the KP quality also. The purpose only we are using the image compression. If you are compress the images without damage, I need to compress the purpose only mostly we are using the image compression method. You know? You will compress the image and file also no problem. If you have the entire file you want to compress also it will possible to compress single image also it will possible. Next, fusion method. Image fusion refer to the process of combining two or more images into one comparison. After that, you will get the some individual images. For example, if I am giving one images, okay, some dog images. After that, they will apply the pre-processing. They will apply in the fusion method. Okay, segmentation is different. Fusion is different. Segmentation, they will show the color like this. Apply that. But in the fusion purpose, they will converting only for the black and white type only now. Okay, this is a fusion method. After applying, they will recognizing this is a cat or dog or female, sorry, male, sorry, human. Like this, they will converting. They will identify. That is the use of fusion method. Next, retrieval images. Retrieval is nothing but similar images. If I upload the own images, I need to check about the similar images. Similar image means, for example, in that I have one folder, image folder. In the image folder, I have 10,000 image will be there. Okay, 10,000 images. I'm not able to check one by one images. One images I save the two time. Okay, that time what I need to do, if I have the image retrieval option, I have one images, but I don't know how the another copy image also. If I upload the other images, they will check in my image folder. They will find out. This is the use of image retrieval. It is look like Google Lens only. In the Google Lens, whatever what we'll do, if we have one images, they will crop. They will check the Google Lens mean. They will find out. For example, you need to purchase some shoes, but you don't know about which website they are available from the source or chapel means. If you will go upload the Google Lens, they will find out. Same like this only, we are using the retrieval option also. Okay. Next, security. Security means we are having the three method: cryptography, steganography, and watermarking. Okay. These all are comes under security method. You have any doubt from that before techniques? These techniques purpose, I will show some basics one by one example. How to read the images, color conversion, and filtering method. All thing I will type some coding part. You will get some idea. Okay. After that, we'll discuss about the security application also. 1 minute. For example, I need to read the one images. Based on the images only, I need to do about the my techniques. Okay, na? Based on the images only, I will do about the techniques. Otherwise, in the Google Chrome, I need to download some images. Based on the image only, I want to read color conversion and all thing I need to do about. Otherwise, in the Google Chrome, I want to download the images. I think all our system they have the MATLAB means based on the step by step. Once to do that, first I need to open the Google Chrome. The Google Chrome, you download some images. Okay. Mostly first you can try about the JPG images. JPG images you can download. Okay. I download that image. I will save some separate folder. In the desktop, you create the MATLAB folder also. Inside the folder, you need to save the images. My image name is Virat Kohli. Okay. Na? Otherwise, I change the image name. One you mention, one.jpg like this. I mentioned the one. I save the images. Okay. Na? Now I open the MATLAB. In the MATLAB, already you create the one folder, correct? Once open the folder, 1 minute. Already I create the one folder, the MATLAB. Inside the folder only I save that image. This image I need to read the purpose. what I need to do mean the entire file path I need to copy. You need to create the one folder in desktop or any place. You need to create the one folder. The folder name is MATLAB. Like this, you need to create. After the opening, here you need to select copy the path. Okay. Already I have the MATLAB. I open the MATLAB. Here I need to paste. Enter. After that, I need to open the new script. Correct. Here, new script I need to open. And type the code for the first image reading, color conversion, and one by one we'll go about that. Okay. 1 minute. First, I want to read the images. If now, if you are using the Python means, we need to add the command window. We are using like this. Okay. Na? But if you in the MATLAB, you want to add the command window means you need to add the percentage symbol. The percentage will be the symbol you need to mention. I need to add the heading, read the image. I need to create the variable name img equal to I am read. This is a keyword I am read. Okay. Na? Image equal to I am read. Which image you want to read that? The image name is this only. Automatically they will refer. Why means I save in my code location only. That's why they automatically refer. JPG. If you are typing the any code in the MATLAB, end of the session you need to add the colon. Semicolon you need to mention. Okay. Na? After the enter button, that image I want to show. That's why I am so. Which images? That variable name. IMG variable name I need to display that. Okay. Colon is mandatory. After that, I need to add some title. Title. The title name is original image. Okay. First, I mentioned the condition for the read images. IMG variable name I need to create equal to IMRead. This is a keyword of MATLAB. I need to read the images. That image name is 1.jpg. After reading that image, I want to display that. I am so. I need to show the image. Which image? This variable name image I want to show that. The image purpose I need to add the one title. If I will execute the code, I need to save the code. It will read the images. Okay. 1 minute. Okay, this is only for the image reading. If you want to convert into the color means image color conversion like this, we are having the separate method will be there. This all code I will share in your the MAM number. I will share the code in MAM number once you collect, and whenever you have the free time, once you check that. Okay. Now we'll go through about that security method, security applications. Security application means we are having the three application, cryptography, steganography, and watermarking. Mostly where I need to use security method means, for example, um, Indian government, they will transfer some data to the Russian government. Okay, they will transfer the data, but between the gap, any another country they possible to hack in our data. They possible to check in our India and Australia India and Russia convocation. It's possible to check. The purpose we are applying the cryptography, steganography, and watermarking method means you need to share one image only, but inside the images they have the content. But if you hack my system, if you hack my data, it look like image only. But inside the image, we have the content will be there. Inside the image, I had some text. If I will share for example, I will share the WhatsApp. In my WhatsApp to another WhatsApp, I will share the images. If you check any another one, people mean this look like image only. But we have some secret key will be there. The people they enter the key in the images, they will display about the text. This why means I want to transfer the data, but between the gap, anyone people possible to hack, they no need to check my data. The purpose only I share the images, but inside the image we have the text. After receiving, for example, I want to transfer data to one number to another number, they will receive the image only. After that, they want to enter some key. After enter the key only, they will show about the text. That is comes under security method. Mostly where we are using the army people, that most of the army people only they will using about the like this application for the cryptography, steganography, and watermarking. Okay. Okay, next image processing application. This is the main thing. Face recognition application, number plate recognition, land detection application, automatic parking, driver monitoring, drowsiness detection, and all things. Forensic based document retrieval, formal and graphic sign recognition, film industry. These all are MATLAB applications. MATLAB we are having in the MATLAB. Most of the development will be there. Nowadays, most of the company they want the MATLAB based on that developer only. I mean, I already said that most of the people they want to go about that image processor, Python, Java, MainStack, React like this. If you strong about the MATLAB means you'll study about any MNC company. I mean, MATLAB they mostly they won't use about startup based on the company. Mostly MNC based on the company only they will use the MATLAB. That's why only I will most of the student purpose I will refer about the only for the image processing. Sorry, image processing with MATLAB only. Okay, these are applications. Finally, I have one coding part. I will show the coding part. We'll get the idea from the image processing how the coding part it will work. This is comes under the brain image, brain tumor classification, brain tumor detection, and segmentation. I paste it here. They will display my images. I open gu.m. Here. I need to run. It will open on GUI window. If you are, some people know about the Python and all things. The Python purpose, we are using HTML and CSS JavaScript. It is for the interface. Same like this, the MATLAB purpose, we are using an interface. It is GUI, graphical user interface we are using. The interface, I click the button based. I click the MRI image option. I will select the one images. I click the open option. These are brain images. After applying the pre-processing images, original images, they will display here. These are original images. Okay. These are after applying the pre-processing method. Next, I need to apply the TWD method. Okay. If you have that, means we have some block diagram will be the input image, pre-processing. After that, I need to apply segmentation method. Segmentation means you need to use about the TWD, discrete wavelet transformation method. I need to apply that. Okay. What is the use of segmentation? Mean the identification the edges of my images. That is the use of segmentation. Segmentation we are having the LWD also will be there. Mostly we need to use about the TWD, otherwise K means clustering like this. We are having the different type of clustering will be there. Now I need to use the TWD method. Okay, I am already giving the input. Pre-processing method also completed. Next I need to apply segmentation. The segmentation we have the TWD method. Okay, they will identify only for the edges of the images. Next I need to train with my database loading. I want to train that. The training purpose, which algorithm we are using? I am using the CNN algorithm I am using. Here they mention training and classification is completed. Okay. After that, detect the stages. Stages means is a normal or tumor. Like this, I want to check. Showing about brain tumor. This is 0% effect only. 0% effect means this is a normal only. If I apply segmentation method, they did not display. Why means this is a normal only. Normal purpose, no need for segmentation now. Where I need to apply segmentation mean if identification is a disease only, I need to identify the segmentation. What is the use of segmentation means? I need identification of the place. For example, I giving the MRI images, the identification, this images is affected image only, but which place is affected? That I need identification, correct? The purpose only we are using segmentation. Okay, I click the clear option. Next, I will go the MRI images. I will select any another image, open, TWD method, database loading, completed, detection of stages. It will showing about brain tumor. This is 50% affected. This name is malignant. If now apply segmentation method, showing the process. Okay, this is segmentation. This place only they affected the disease. Okay, na? This is segmentation method. You want to zoom in, zoom out, and all thing option is possible. Okay, na? I selected from one images, open. Okay, they will apply that. This place only they affected for the disease. After that, I click the result analyze. They will show about some graph. Sensitivity, specificity, and accuracy graph, they will display that. Okay. This is for the one coding part. The same coding part you can do about the lung cancer, breast cancer, newborn detection. After that, skin disease, like this skin disease, traffic sign, face recognition, and all things you need to go about step by step. It is possible with MATLAB also. Okay. If you connect with hardware to the, if you want to do about the hardware project, most of the people they use the Python means you can use the MATLAB also. The MATLAB also we have some toolkit will be there. If you install the toolkit, you can execute the hardware code, hardware and MATLAB code also possible to combine. Okay, na? This is the coding part. Okay. Okay. Today's section, any doubt will be there? Any questions? Any queries? Any doubt? Today's section. If you upload the another image, they will show the another output. Wait, I will show that output also. Open. TWD method. Database loading. Reduction of stages. They will show 30%. End of the segmentation. They will show cancel. Select some images. They will apply the affected places. They should analyze. Here they will mention the area name also. Finally, they will show about the graph. Okay, na? Okay, sir, how I need to create the one GUI? That also I will explain. This purpose I need to open the command window. Wait. Okay, na? This is a GUI window. The GUI windows are here. I need to change that text color. I need to change another means whatever this place, need to click right click option. Property inspector will be there. I need to click. They will display some another option. Maximize the screen. Here text color will be there. Na? Blue color purpose. You can change for the another color. Okay. After that, the name also need to change, font size and all thing will change, font style format also you can change. After that, click save option, close the one, it will change automatically for the each one by one. Okay, na? You want to create new means, now I click the new option. Okay, this is a blank. Okay, na? Here I need to create one new things. First I need to add the button. Select and add the button. One by one button I need to add. Okay, I added a 3 button. Okay, na? Each button purpose I want to display some images, correct? So down here I will add axis 1, axis 2, axis 3. If I click the button 1, I want to display the image in the axis 1. If I click the button this one, I need to display the axis 2. If I click the button 3, I need to display this image here. Okay. After create this one, if I click the save option, I need to mention that let by big only. Separately, they will generate the one code. In the code, they will mention the button option. Wait, I will show that. Button 1. This is the button 1. The button 1 downside, whatever you want to condition, you need to write. Button 2 place, whatever you want to do about the condition, you need to write that. Based on the button wise, sometimes this it will display behind the axis will be there. No? I want to display some images. Based on the axis wise also, they will display that. For example, here I want the condition mean this comes under the button 1 and the axis 1. Here I want type the condition mean this comes under the button 2 and the axis 2 also. Okay, like this only need to create the content. Okay, now if you have any doubt, any queries, any doubt, today's section, any doubt? One minute. You have any queries?
Dear students, if you have any queries, please unmute yourself, raise your question, or you can post your question in the chat box. Yeah, so far no questions, sir. Thank you for your session, sir.
Thank you, ma'am.
So theoretical concepts, including the code, you nicely taken them from the basics to the applications. Thank you for your session, sir.
Thank you, ma'am. Thank you so much. Thank you, student. Thanks to all.
Yes, sir. Good evening, Dr. Lenin, sir. Dear students, please stay back. Other session is going to start in 2 minutes. Already resource person joined. Sir, am I audible?
Hello. Hello.
Okay, Nishani. Hello, Lenin,
Yeah.
sir.
Yeah.
Yeah,
Am I
your
audible
voice
now?
is clear. Are you able to share your screen from your end?
Yeah. I'll share. Please give me a minute.
Yeah, okay.
Yeah, can you see my screen?
Yes, sir. The screen is clear. Your voice is also good.
Okay. Thank you.
Yeah, 1 minute, sir. Sahasra?
Yes, ma'am.
Yeah, please introduce us, sir, for the session.
Yeah. It's my privilege to invite you, Dr. Lenin, sir. He holds an MTech in microwave and radar engineering and a PhD in the field of antennas. He has extensive experience in the field of antenna engineering. His expertise lies in the research and development of antennas defense, personal communication, space, and 5G telecom applications. He has published several research papers in reputed international journals and conferences and holds 7 patents to his credit, reflecting his strong contribution to innovation and advanced research in antenna technology. Over the years, he has worked with multiple reputed organizations, including DRDO, where he served as a scientist. Currently, he is working as a director of engineering in JMA Wireless. It's my privilege to invite you, sir. And sir, the session is all yours.
Thanks, Asra. Good evening, students. So today I'll be going through some of the communication antennas and how you can use the MATLAB for a design. Okay. So if you have any doubt or if I ask you any question, you can respond then and there itself, or you can text in the chat, send a text in the chat. Okay. Okay. By any chance, have you seen these towers or anywhere within Hyderabad? These pictures are one of the picture is from Hyderabad, Chamtalpunta. Okay. So if you have not seen or even if you have seen it, these are the nothing but antennas used in AM and FM broadcasting, mainly for the radio broadcasting applications. Okay. So what I will do is I will try to give some insights of where the antennas are used and how the antennas will look like. And this is another tower which you see in Dilshuk Nagar. This is called the famous TV tower Dilshuk Nagar. This is also one of the biggest antenna used for broadcasting the Doordarshan signals. Okay, so since I'm talking about antennas, it is logical to visit what are the frequencies, what are the different types of uh, at what different frequencies the energy used for different applications. Suppose if we start with the lowest frequencies we use for AM broadcasting, FM broadcasting. I'm not sure how many you know, how many of you know there is one item called AM broadcasting, and now we all listen to FM radios. That is through FM broadcasting. And next comes the TV broadcasting. So for all those, we use frequency up to around 250 megahertz kind of thing. So then the personal communication starts, where we use for general walkie-talkies or the cellular phones what we use now, and then comes those are called the radio frequency signals. Then comes the microwaves. So as the frequency increases, the wavelength becomes smaller and smaller, and the propagation also the distance of propagation becomes lower. So if you go back to the FM signal, so for entire Hyderabad, to cover entire Hyderabad, probably one tower or two towers will be sufficient. Whereas for telephone signals, the mobile cellular signals, it is not like that. You see for every couple of kilometers, you end up seeing a cell phone tower, which we call base station antennas, base station towers, basically. Okay, so that is due to frequency increase, so they cannot propagate for longer distances because of the atmospheric conditions, where the signals will get attenuated and they die down fast, quickly. That's how we end up establishing more base station towers. Okay. Next comes the microwaves. So hope most of you have microwave oven at your home. So again, these are also microwave uses microwave energy for heating your food items or whatever application you use it for. Next comes the infrared, visible light, ultraviolet, X-rays, gamma rays. All these are in the microwaves. All these are microwaves only, falls under RF energy. Based on the frequency, we have identified different applications and it has been widely used. Okay, so now coming to the mobile communication. So now we are using, I think most of you are already using 4G, 5G, or at least a 4G network. Okay, so in 1980s, we got this 1G mobile phones which were very bulky. Later, it got developed to transition to 2G, then 3G, then 4G, and 5G. So, what is the basic difference? If you see the bottom blue color numbers, so for a 1G application, the theoretical maximum speed is 2.4 kilobytes per second. Whereas with 5G or at least 4G, we are talking about 1 Gbps. There is a huge difference. So how that is achieved? Okay, and also suppose if you want to download a decent movie, so the estimated download time is suppose if you want to download a movie of 4 GB size, which is written here. Okay, so by using a 2.4 kbps, it takes 4 months and 27 days. Nowadays, we need everything very quickly, and no one has patience to wait for such long. So no, so accordingly, the technology is also transitioning, and now we will be able to download that same 4 GB. Of course, practically at some places it is not feasible, but theoretically, yes, within 30 seconds we'll be able to download that 4 GB of video file or whatever data file it is. Okay, and when you go towards 5G, yes, already the 5G services has started. Okay, even though we don't see very high data speeds, but we definitely in some places, especially within Hyderabad or within crucial critical points within the Hyderabad, we can see higher data rates. Again, it is based on the type of infrastructure they have deployed there, through which this particular download speeds are feasible. Excuse me. So, how all these things are possible? So, what are the frequencies we are using for 2G, 3G, 4G, and 5G? So, there are different types of frequency bands involved within these technologies. So, suppose if you see 2G, it uses some set of frequencies calling 824 megahertz to 894 megahertz and 1850 to 1990 megahertz. Whereas 3G, it uses a different set of megahertz at the higher frequency. 4G, it uses majority of those frequencies plus some additional frequencies. When it comes to 5G, it uses all of the 4G LTE frequencies and some more additional frequency bands. So by optimizing the network and by deploying infrastructure at different frequencies, we are able to improve the data rates or the speed of communications. That's how it is possible. Okay, so have any of you seen any antenna physically? Madam, all these are third year and second year students, right?
Yes, sir.
Okay. So have you did anybody see any antenna physically? Okay. Or are you aware like how many antennas you are having with you or with your mobile phone? Inside your mobile phone, there are multiple types of antennas. Does anybody have any idea what are the frequencies we are using and what are the probable antennas we can have? So we have Wi-Fi within our mobile phone. We have Bluetooth within our mobile phone. Okay, we have normal. We use 4G, 5G. So if you go to rural areas, so if you go to outside Hyderabad or if you go to any rural area, then you will not get 4G signal. Then it will drop to 3G or 2G type of communication. If you go to interiors of the city, where I said where advanced infrastructure is installed, there you get 5G. So it has to, as I said, like in the previous slide, this slide, so it uses different types of frequencies. So for every frequency band or every application, it requires one antenna. Means the more flexible your mobile is, that many antennas will be there in the mobile. So this is the typical picture of one of the smartphone, where you can see the antennas are highlighted in blue color on the left side. So you have a GPS antenna, you have a LTE MIMO horizontal polarization antenna, we have LTE MIMO vertical polarization antenna, we have Wi-Fi transmit receive antenna, we have 2.5 GHz Bluetooth antenna, we have PCS CDMA antenna if it uses, if it provide supports that particular band. So these are the bare minimum number of antennas available in any mobile phone. Okay. The one more thing is, just in the previous slides I have mentioned, like we used this microwave energies or the RF energy for microwave applications for heating our food and all. That microwave oven, the microwave oven works at 2.4 gigahertz. So as the Bluetooth and the Wi-Fi antenna. Okay. Also nowadays we are using earbuds. So wherever wireless is there, there lies one antenna on both the sides. So it has to be connected through antennas only. So whatever you are using wireless, if you use a wireless headset, it has inbuilt antennas. If you use wireless earbud or earphone, it has inbuilt antennas. Means it is continuously radiating. At what frequency? So for connecting to earbuds or earphones, we use Bluetooth, right? So it is around 2.4 gigahertz. Our microwave oven also uses 2.4 gigahertz. So please be careful if while using these devices for a on a long term basis, because our ears brain is getting heated up. Okay, so it is not advisable to uh, use for very long periods, all these wireless devices. So be careful. So have you ever seen this kind of structures within city or anywhere? Like not exact, need not be exact, but you see multiple cell phone towers within the city or wherever you go, right? So on those towers, there are some tube light kind of like that white bars kind of things. So those are nothing but antennas. So those are phased array antennas having different frequency bands, multiple antennas within a single structure, like within single that tube kind of thing. We call it as a radome. So in that radome, you can find up to few hundred of radiating elements which are required to radiate this all these cellular signals in order to provide us mobile communication. So what it does, so on the top right, so if you see this picture, so on the like a relevant the shaded area, so the antenna is actually radiating in this fashion. Means it is pumping energy in this area. It can be up to from 50 to 300 meters range, or if it is very low frequency, it covers up to a couple of kilometers, depending on the frequency we are using in this antenna. So this illuminated means we are illuminating the some particular area using RF energy. Nothing but we are trying to put some light. If you put some light, will be able to see that particular area. Similarly, if you illuminate the RF energy on a particular region, so you will be able to establish communication between the user's mobile phone and to the cellular tower. So that's how the communication happens. So this is the colored radiation pattern is the typical coverage pattern, wherein in the elevation means from ground, if you to go towards the upside, upward towards sky, we call that as elevation, and from left to right is called the azimuth. So azimuth, it has to see wider area, and elevation, it need not see much area unless there are any high rise buildings. So depending on the area of deployment, if it has high rise buildings, different types of antennas will be used. If it has medium rise buildings like the 5 floor apartment kind of structures, we use different kind of antennas. If it is only a rural area wherein the density, population density is less, and it has to cater for a larger area, there different types of antennas has to be used. Okay, so this is again another picture of the coverage. It has the different components like side beams, main beam. Okay, so yeah, I'm not going into those particular details. Okay, so here in this session, what I want to cover is I want to cover few types of antennas, and ultimately I will focus on patch antenna design using MATLAB, since this is the program related to MATLAB, how to use MATLAB in antenna designs. Okay, so these are the different types of antennas available. These are few of the different types of antennas: wire antenna, slot antenna, printed or PCB antennas, reflector antenna, dish antennas. Where you see different types of dish antennas for your Airtel or dish connections, horn antenna, lens antenna, and phased array antennas. So this is the radiation pattern, a typical radiation pattern of a single element, means any antenna, single antenna. So here we call the radiators or the antennas, we categorize them into single element arrays, linear arrays, planar arrays, which I will cover few of them in the next slides. So this is typical radiation pattern of a single radiating element, where we uh, characterize or analyze based on the azimuth radiation pattern elevation, or if you want to speak in technical terms, H plane and E plane in terms of fields. So that's how we characterize these antennas, or we select different types of antennas for different applications. Okay, and again here half power beamwidth. So suppose in cellular communications, a cell phone tower is supposed to cover all 360 degrees around this around the tower. So for that, we have to use different multiple more than one antenna to cover effectively the entire space. So there we will use this half power beamwidth terminology uh, to decide how many number of antennas are required to cater the 360 degrees surrounding that cellular tower. Okay, and if we go to advanced or next level, so this is how the radiation pattern can be adjusted to cover a particular area. Example, you live in a place where Airtel is like you where you have Airtel connection, but whenever you try to call, you get frequent disconnections and all. So what you do, you complain to the customer care saying like my call is getting disconnected or there is no coverage, or the service provider like Airtel themselves will keep monitoring the call quality and identify the or rectify areas where they're having frequent call drops by adjusting the or optimizing the radiation coverage by using phased array antennas. Okay, so the right side bottom one is the typical radiation pattern of a planar array antenna. Okay, so I'll jump into some basic like antennas, printed antennas. Okay, so the printed antennas can have different shapes like a rectangular, square, ellipse, circle, and it can have any shape. Need not be this. It can have any shape. For today's topic, I have chosen a rectangular patch antenna. Okay, so for ease of explanation and to explain how to design this patch antenna easily using MATLAB equations. Okay, for any basic antenna, whether it is a dipole antenna, monopole antenna, patch antenna, horn antenna, there are uh, uh, design equations available in literature or your textbooks readily available. The main thing is to just convert them into program and make them flexible for designing any type of structure using them. So the printed patch antennas can be fed using different feeding methods. So these are four different types of feeding methods. One is microstrip line feeding, the first one, the bottom left one. Second one is the coaxial probe feeding. Third one is the aperture coupled feeding. Fourth one is proximity coupled feeding. So in your BTech, you will have definitely you are going to have antennas as one of the subjects, I think. So which will uh, which will have all these topics covered in detail. So coming to further in depth, there are different types of polarizations in these antennas. Some are linearly polarized. Within linear, we call them vertically polarized, horizontally polarized, and circularly polarized, elliptically polarized antennas. So these are the different types of feeding techniques for getting circular polarization. So what is this polarization? Suppose uh, suppose if it is a vertically polarized antenna, so all these AM broadcast, FM broadcast, all these antennas use linear polarization. Whereas satellite communications, they use circular polarization. Why is the difference? Because on ground, the linear polarized antenna, it can travel to larger distances without getting the polarization disturbed. But whereas in satellite communication, we need to align to the respect to transmitter and receiver has to align themselves to the respective polarizations. Otherwise, the communication will not happen in any application. So here, the personal communication case, where we generally use linear polarizations. In satellites, since the satellite is far away and we don't know the orientation, we end up using circular polarization. The circularly polarized antennas are generally complex in nature, unlike the uh, linearly polarized antennas. And in telecom applications, we use dual polarization. Dual polarized slant polarization we use. Okay. So that is a 45-degree oriented plus 45 and minus 45. Dual slant polarization is what we use in telecom applications. Coming to the design of microstrip patch antenna. So as I said, like there are equations for everything. So the left bottom is the picture of the patch antenna, which has width W, length L. Epsilon r is the dielectric constant of the substrate, ground plane. So basically, a microstrip patch antenna will have one ground plane, one substrate. It can be anything, either air or non-metallic, basically with some dielectric constant. And above that, we will have a metal piece shaped such that it radiates at a particular frequency. So that shaping to make it work at a particular frequency, we need some frequency details and what is the polarization required, what is the gain required, what is the beamwidth required, axial ratio, bandwidth requirement, return loss requirements. All those will come into picture while designing or arriving at the shape of that particular radiating element, which is the patch here. So here this patch has W. So for every parameter, there is a equation for width. It uses C is the speed of light divided by 2 into the frequency, and epsilon r is the dielectric constant of the substrate which we are using. And there is another epsilon r effective, which is the effective dielectric constant. So that also has equation. So that comes into picture due to this fringing fields, the arrows which are marked on the left and right side of this patch antenna. So due to that, the effective length of the patch will increase, and we need to consider or take that into consideration while arriving at the dimension of the patch antenna. So delta L is that additional length, and based on that, or after calculating the delta L, we arrive at the actual length of the antenna. Again, conductance. So, madam, so these people are not aware of the impedance transmission lines, right? The students. Hello. Hello, can you hear me?
Yes, sir.
Yeah, so they are to study the transmission lines, right? Subject?
Yes, yes. Now in third year, it is there.
Okay.
Mm.
Okay, because the impedance, conductance, all those parameters or the terminology, they might
Our
not understand.
terminology is known to them.
Oh, terminology is known to them.
Huh.
Okay.
How to
Okay.
connect with this concept, we need to explain them.
Okay, okay. So every patch has a like a edge impedance which we need to calculate, and so I have used the microstrip transmission line to connect this feed this patch antenna at some particular distance inside. So how to arrive that? So the next set of the right side set of equations will decide or will let us arrive at that point based on the impedance of the transmission line we are using. Okay, coming to the again, so this is the patch antenna. So what we need to feed with is a microstrip line. So we are using microstrip line technique to feed this antenna. So that how to calculate that width, how to calculate that length. So for that also we have set of equations. So all these equations we can implement, or we can implement a program. Once we implement a program, we'll be able to easily calculate all these numbers. Again, there is a concept called impedance transformer, which is required if you go for array antennas. Okay, so here in this session, I'll be explaining a overall like a 4 by 4 planar array antenna, which involves a single patch antenna, 2 by 2 planar array, and 4 by 4 planar array, and uh, the requiring or the relevant feed network design also. So we use 1:2 power dividers here. So we need to, when there is a power divider, we will definitely end up transforming the impedances from input impedance to the required output impedances, ultimately to match with the edge impedance of the patch antenna. Okay. Uh, so I have all the MATLAB programs available. You can contact your coordinator to get those programs. So those programs should run directly. Otherwise, maybe those are created in a different version, and the word files like auto correction might have changed a few of the syntaxes. Otherwise, it will run easily. Okay, so every for all these equations are written in the form of a program, and the program will wait. Let me display the program also. Okay, can you see my screen? Programs.
Yeah. Yes.
Okay, so this is the MATLAB program. So these are using, like, this program is using basic commands only. Okay, so what we have to do is everything is written here. This program calculates dimensions of the patch antenna, patch, insert feed position, corner truncation, slit lengths, edge impedance, everything. Like, so all the instructions are clearly given in this program. So it will ask for comments, like it will, once you run this program, it will ask for your inputs. Enter the height of the substrate in centimeters, frequency, enter frequency in gigahertz. Okay, so dielectric constant already I have fixed it as 2.2. You can change it depending on the substrate available. Okay, and it will calculate the width, effective dielectric constant, length, display effective dielectric constant, everything. So once it completes, this screen is also visible, right? Yeah, okay. So once you run the program, so all these dimensions will be available, and also the program is made such that it generates this particular drawing also, the right side patch, not these markings. So this structure it generates. Why I have done is, since my target was to do a 4 by 4 array, I have taken this extra effort of generating the structure also. Otherwise, we can do the same drawing in AutoCAD or some other CAD software. Okay, so this is up to single element. So there is a concept called antenna arrays. Why we need arrays? Why, what, how? So why we need arrays? What are those, and how to make them? So suppose I have a I have a my frequency is fixed. I have one kind of radiating element, patch antenna. Okay. So example, I have selected 6 gigahertz, like the one used in this program. But the target is to cover more distance. So what is the best way? So by adding more elements, okay. So if you see the left picture, so the dots indicates number of elements. As you increase the number of elements, the gain of the antenna is increasing. Means it is trying to focus all the energy coming out of these antennas in a constructive way to a particular direction, so that it can cover longer distance. Okay, in one direction, definitely nothing is free. Nothing is free, nothing comes free. So it is just modifying the shape of the pattern such that it covers longer distance instead of longer width width. So lengthwise it is covering more distance by adding more elements. So this is called array concept. So in this array itself, we have linear antennas, planar arrays, linear arrays and planar arrays. So the base station antenna, which we have just gone through just before in previous slides, so it uses linear antenna. Linear antenna means one direction it makes the beam narrower, other direction it keeps it wider as a basic patch, basic radiating element. So this is how the linear antennas can be made. So it has again different feeding techniques: series feeding, parallel feeding, corporate feeding. So this is where we will end up designing the uh, power dividers, which I was showing as for two-way power divider and transformer. So we need to transform from one impedance to other impedance. Example, if you consider the middle one, you have an input here. Example, you are sending 100 units of some like power, 100 units of power. So what is the expectation? It has to divide into two equals, 50 plus 50. Let us assume it as a big pipe, a water pipe with 100 mm diameter. So if you have to divide it into two equal halves, towards the top side and the bottom side, what you need to do? You need to attach two pipes at the junction. So in order to divide it into 50 plus 50, what is the best way? You have to connect a 50 dia pipes on both sides. You need not use 100 If you use 100 on both sides, it will create an imbalance and the transfer will not be proper. So 50 plus 50. Again, that 50, okay, there should be another picture. So again, that 50, it has to get divided into two. 25 plus 25. That 25 will divided into 12.5 plus 12.5. So accordingly, you need to select the size of the pipe for water. Similarly, for RF energy also, you need to select the appropriate impedance of the transmission line in order to transfer the energy efficiently. So, and for estimating the radiation pattern of this linear array, so the left side given equations will be helpful in writing the program. So the same program is implemented in the MATLAB. So this, if you run the program, you will be able to see after this program. So we got the results and the single element structure is given. The next program is width of the feed. So we need to calculate widths at different levels for 100 mm, like I said, for the 100 mm, 50 mm, 25 mm, 12 we talk in terms of impedance. So the input impedance will be 50 ohm and the patch edge impedance will be around 200 ohm. So how to match that? So 50 will ultimately get divided into 100, 100 will get divided into 200. So practically, there will be some practical constraints in designing a 200 ohm transmission line. So we transform it to a next higher number and then again split it. So for calculating all those things, so this second program helps. Okay. So for an impedance of 50 ohm, the width is okay. So width is 4.9 mm for a substrate of 1.6 mm thickness. For 100 mm, 100 ohm width, so enter impedance 100 ohms, enter dielectric constant 2.2, enter height of the substrate 1.6 mm thickness. So width of the feed is for 100 ohms, it is 1.4. For 70 ohms, it is 2.81 mm. So all these widths we can calculate very easily by implementing this program. So what you need to do is you need to run this program 2, and you'll be able to calculate all these things or design a full patch antenna actually. Next program is for calculating the theoretical radiation patterns. So so the left side equations can be used to estimate the radiation patterns of this linear array. So like in this picture, for a number of elements. So it calculates from 2 elements to 30 elements. It is calculating, right? So similarly, whatever pictures you are seeing on the right side animation, thus all those things you will be able to compute or generate using this MATLAB code. This is the two-dimensional radiation pattern. Okay, next comes so I told like there is a linear array. This is a linear array, and it is giving some different radiation pattern. Suppose the side items we call as side lobes. So if we don't want this much energy to be wasted in the side lobes, there are different amplitude tapering techniques. Uh, Uniform weighing method. Okay, so if you use uniform weighing method, we'll get a side lobe of worst case side lobe of 13.5 dB side lobe level. If you use a different taper method, so here what we are doing first case, we are giving all elements equal amplitude and phase. So for that, we are getting a narrowed beam with side lobe level, worst case side lobe level 13 dB. Suppose if you don't want this energy to be present here, means you don't want to give any or do any communication in this area, and you want to focus all your energy only in the central region, then you need to implement a different amplitude tapering technique by which you could shape the radiation pattern as on the right side, right bottom. Okay. So here we got first case we got 13 dB side lobe, second case we got 40 dB side lobe. So where these kind of requirements will be there? Example, there is a satellite communication wherein the antenna is designed and you want to focus only on India and you don't want to lose or leak any data to the neighboring countries or if not India, some, yeah, example India, and you don't want any data to be leaked to the neighboring country. So this is one of the approach to minimize energy leaking or avoid energy leaking into the adjacent areas or unwanted areas. So this kind of techniques, these techniques will be used in such cases. Okay, next is the planar array antennas. So again, planar array antenna means linear array antenna. We are using multiple number of radiating elements in a single line. We are assembling them like maybe 10 elements, 15 elements, or depending on the requirements. The more the number of elements, more gain it reaches or it can cover more distance. But the other plane, it will the beam it will get narrowed down. If you want both the planes x and y or both the directions to narrow down, then the next approach is the planar antenna. Means use radiating elements in a rectangular or square or circular grid kind of environments. Means you will have in both directions elements so that you will get a narrow beam in all the directions. So these are a typical planar antennas. The first one, this is a helical planar antenna used in satellite communications. This is from a ground station in used in satellite communication. Okay, the top one is a planar patch antenna using a corporate feeding network most probably because it is the feed network is in the next bottom layer. Next is the series fed planar array antenna, the second one from top. The last one is a slotted planar array antenna. So all these type of antennas are widely used in satellite applications, defense applications, radar applications, and also used in aircrafts, wherein you need a very symmetric beam in all directions to uh, communicate with your point of interest. Means suppose if there is an aircraft, where you want to communicate to, you need to communicate to the ground station on the like on the at the airport or air base. So it will be only communicating with particular in that particular direction. Okay, so using the program or as part of this program, what I have done is initially I have shown you like a single element can be designed using that code. So later, the objective is to design a circularly polarized antenna. So to achieve circular polarization, this one of the corner truncation technique is used. Okay, so this gives a fair degree of circular polarization purity. So by using that element as a basic building block, the 2 by 2 planar array is designed. Here, for any antenna, the basic RF cable what we use will have a 50 ohms impedance. So here the 50 ohm impedance is getting divided into 100, left 100 and right also 100. Later, we are using a transformer to transform it to 50 ohm again by using a quarter wave transformer, which is 70.7 ohm. Again, that 50 again in turn gets divided into 100. Otherwise, if you divide this 100 ohm itself into 200, the line will become too thin and it will be very difficult to fabricate. Okay, so to avoid that difficulty, we have to transform back to 50 ohm and then divide it. So it happens like this. For larger arrays, definitely, so 100 will become 200, 200 will become 400, and those are not at all practically realizable. This itself is 1.4 mm, 1.4 millimeter. This 100 ohm transmission line width is for 1.4 millimeters. If it is 200 ohms, it might become zero point 0.7 millimeter. For 400, 0.35 millimeters, which are hardly like a, very difficult to see or touch or control the widths in fabrication. Very difficult. So the right side one is the 4 by 4 planar array, which is designed as part of this activity. Okay, so So the theoretical radiation patterns. So there is a MATLAB code again, um, patterns 2D. So 2D radiation pattern. So we call the left, the circular one as the 2D radiation pattern, and the right side colorful one is the three-dimensional radiation pattern. Means we are uh, plotting the three-dimensional radiation pattern in a rectangular fashion. So the left one is a polar plot, right side is a rectangular plot. So the radiation patterns, in general, they'll be plotted either in polar plots or rectangular plots. Okay, so by using that frequency MATLAB program, so we can generate this 2D radiation pattern like this. It comes like this result. Okay, so it has both elevation and azimuth depending on the number of elements in azimuth and elevation. So here, what we are say taking is n number of elements in the array. I think the inputs are not here. Okay, so you can experiment with any number of elements, and you can see all the radiation patterns getting generated. Next comes to the three-dimensional radiation pattern. So this has elements in x direction, y direction, element spacings. Okay, so if you give all these inputs, you will get the radiation pattern like this. So this is the three-dimensional radiation pattern of a 4 by 4 rectangular array. Okay, so this is for the 2 by 2 planar array, two-dimensional radiation pattern, three-dimensional pattern radiation pattern generated using MATLAB. This is for the 4 by 4. So you can choose any number of elements, and you can generate like by increasing the pixel or the step size or reducing the step size. And if your PC permits, you can generate beautiful three-dimensional radiation patterns for any number of elements, whatever you choose. So it need not be perfect square like 4 by 4. You can generate for 2 by 4, 2 by 8, 1 by 8, all those stuff. Like you can generate three-dimensional patterns for any size of the array. Okay, so okay, this is for designing. So what else we can use for we can use this MATLAB for, and what is this signal processing, where it comes in terms of antenna arrays. Okay, so now we are talking about 1 second. Okay, so beyond 5G, 6G. Okay, so now we are using 5G technology, and we are expecting the 6G technology also to come into picture. Of course, it can take a few more years to get it stabilized. So there, now itself, we have seen a drastic advancement in the usage of this internet technology, and how we use communication. So the kind of apps we are using, the kind of communications we are doing, video calls, okay, app bookings, e-commerce sites, everything we are able to use. In future, once the 5G fully establishes or towards 6G, we are going to have massive arrays, array of antennas, okay, or intelligent surface, large intelligent surface and surfaces to direct the beams, or we will end up having more and more users demanding more data. Suppose now itself, if I go to, or if I open my mobile, I don't expect any lag to download any video or anything. So how that is possible? Similar to me, there will be few, at least few tens of people trying to download in a similar fashion within the same zone near me. So how that is possible? How the base station is able to cater that? So what it has to do? So what it will do is, see, as shown in the picture, so it will try to cater individual user. It will start, or it will go towards catering an individual user based on the demand. Suppose if a user is just speaking, okay, it will deploy, or it will allocate some specific bandwidth to accommodate that particular speaking. if I'm downloading a high dense, like a high definition movie, so it will allocate few more or a good number of bandwidth for that particular user. If it is a vehicle communication, it will alert differently. So how that is possible? So that is possible by processing the signals or the responses it is receiving or requests it is getting to the base station. That's how the future communication is expected to be. Okay, so what it does internally. So it will suppose right now I'm trying to access a video content or some high data rate, but I am on a move. So what it has to do? It has to continuously keep tracking my location and also continuously it has to serve me continuously to my need. So there it comes the digital signal processing, direction of arrival estimations, beam forming, all those stuff will come into picture. So this beam forming again, so depending on the incoming signal or estimated direction of arrival of the signal, the planar array coefficients will be altered such that a beam is formed specific to that user and it will be switched between the multiple users in a time domain manner. Means for particular microseconds it will cater one user, next few microseconds it will cater the other user, it will keep on switching. So within that microseconds, all the data communication will keep happening. So the other applications is like a similar like direction of arrival and digital signal processing used very widely used in radar applications for searching, tracking, jamming, and also this upcoming telecom applications. Suppose if you need to capture or download data or establish a data link to a satellite, so what it does? So the ground station antenna communicate with the satellite, which is already uh, rotating in the revolving in the rotating or revolving. So it is in the orbit basically. So it is not constant. So the lower LEO satellites are always moving, right? So in order to keep a like a continue communication, it has to keep on estimating in which direction it is moving. Okay, so whether it is moving towards left, right, front, back, and it should be able to estimate the next position and keep the communication in place. Similarly, in radars also, the current war we are seeing the Iraq war, right? So Iraq is pumping missiles. Okay, Israel is also pumping missiles. They are trying to shield themselves, and also they are trying to attack attack the enemy bases. So how they are able to shield, how they are trying to identify the incoming missiles, how they are able to deactivate or destroy the incoming missiles is by using these techniques, search, track, or jam techniques also by using different types of radars, very high, very advanced radars. They can work over few hundreds of kilometers. So even India has radars which can track at least up to 300 plus kilometers. Up to 300 kilometers, it can track. It can track an object having a size of 1 square meter kind of size. It can track and identify and jam it or destroy it. Okay. So in terms of antennas, the planar, the so-called phased array antennas means in order to generate a beam towards the incoming signal, we need to use this phased array technologies. So wherein we'll be able to modify the amplitude, phase, weights of individual elements in the array antenna and steer the beams accordingly. So this is how we can rotate the beam. See earlier in the earlier picture, the central peak is at a single direction, mid direction. Here we are able to steer the beam by shifting the phase numbers at the elements. Okay, so we can steer the beam to any direction. Okay, so it has again analog beam forming, digital beam forming. Digital beam forming is where the most signal processing algorithms will be used in order to do a digital beamforming antennas. So that is more of advanced technique, and also these are very widely used in radar applications, digital beamforming. So in analog, we directly give amplitude and phase to um, antenna element. Okay, but whereas in digital beamforming, we deal with bits, bitting, phase bitting, amplitude bitting is what they call. Okay, anyway, I'll not go much deep into this. Thank you. Please let me know if you have any questions, which I'll try to answer as much as possible.
Yes, dear students, if you have any queries, please post in the chat box, or you can raise by unmuting yourself.
No questions.
I think we fed a lot of information to them in single session.
Yeah, yeah.
That
So it is
trying to
little,
grasp.
yeah, little. Actually, I didn't cover much advanced also, but definitely these are little new topics for most of
Yeah,
you.
yeah. For them, this is
Okay. Yeah, but if you have any practical questions also, I will try to answer.
yeah. Yes, students, if you have any questions, please.
सिनेमाची नाव रे ते सिनेमाची नाव ते
Okay, no problem. So if you have any practical questions, yeah, in MATLAB, how do you validate that our? Okay, so MATLAB is mainly for estimations. Okay, so all these antennas we have to fabricate. We can fabricate and measure it practically. Okay, and your question is physically accurate and not mathematically correct. I didn't get you, Sahasra. See, for any antenna, we can fabricate and test the radiation patterns.
I think her question is theoretically, whatever we are proving, is it possible to confirm with mathematical expression or practical measurement?
Yes. Everything follows like all matches. Like everything will match. Theoretical, mathematical, and practical results all will match with minor mm, deficiencies. Otherwise, they will perfectly match. That's what we are doing every day.
Yeah, I think it is clear for them.
When deriving the array factor, why do we assume isotropic radiating elements? Yeah, good question. So isotropic element has a 360 like spear-like a radiation pattern. That is the ideal element which doesn't exist in practical. So we can that is a base for estimating the array factor. But in practical, if we multiply with the actual radiating element pattern, example, suppose patch antenna, if you have a radiation pattern or the pattern details of the single element patch antenna, if you multiply that with the array factor, it will give the actual or the ultimate output of using these patch antennas in that array. So that is for ease of estimation only, isotropic radiating element. Vijayandra. Did I answer you? Thank you.
Dear students, if you have any more questions, please post it in the chat box. Otherwise, we'll wind up. Yeah, there are no more questions. We will start the valedictory ceremony. Before that, I would like to thank Dr. Lenin. Within a short span of time, he accepted our invitation and he has engaged one session for our students. I'm very much thankful to you, sir. Sahasra?
Yes, ma'am.
Yes, our HOD sir and Dean Academics already joined. I think it is a time to start the valedictory ceremony without any delay.
Yeah, okay. Good evening, everyone. With a very great satisfaction and a sense of accomplishment, I welcome you all for the valedictory session of our 5-day workshop of applications of signal processing using MATLAB. Over the past 5 days, this workshop has not just been learning commands or writing MATLAB codes. It has been about understanding how signal processing transforms theory into signal real world solutions. Now, I am very delighted to invite our Dean Academic, Dr. V. Kumaraswamy sir, to share a few words on this occasion.
Good evening, the guest speaker, Lenin sir, HOD, Dr. SPV Subbarao sir, coordinator, Dr. CN Sujata ma'am, and my dear students. It gives me immense pleasure to attend the valedictory ceremony of applications of signal processing using MATLAB workshop. I hope all of you have enjoyed the hands-on sessions. Even though it is online workshop, MATLAB is available for every one of us. So you can work on by installing the MATLAB in your laptops. And I hope the speakers have covered various applications using MATLAB. I really feel happy that ECE department is conducting number of skill development courses to upskill the students in the latest areas of signal processing, image processing, VLSI, communications, embedded systems. So I appreciate the initiatives taken by ECE department, especially the head of the department, Dr. SPV Subbarao sir. Even though in the busy schedules, faculty are taking their time to conduct the skill development courses, even in the beyond working hours. I congratulate Dr. CN Sujata for taking up this initiative, and all the best for all the students. Thank you all.
Thank you, sir. Thank you for your continuous academic support and encouragement. And moving ahead, I invite our head of department, Dr. SPV Subbarao sir, to share his remarks on successful completion of this workshop.
Hello, good evening, my dear students and respected V. Kumaraswamy, Dean Academics, and Dr. CN Sujata, coordinator of this program, and all the resource persons who have taken this program.
Sir, sorry for the interruption. Our chief guest, Dr. Lenin, also available, sir.
And
Director
our
of
chief
Engineering, sir.
and our chief guest, Dr. Lenin, sir, and all dignitaries who are on the dais of the dais. Good evening, all. And I think this program has successfully completed, and the students have gained more knowledge on applications of signal processing using MATLAB. Here, all the basics of MATLAB and applications in signal processing and communications, image processing, and medical image processing have covered here. And students also can do these online RAM courses, and they can get certificate from MathWorks. That will be useful for them. And this type of programs will enhance the skills of the students, and they can useful for doing the projects, solving the problems, and going for paper publications. And I request all the students to take advantage of this program, still continue and do work in these areas that will be helpful for you in your career. I thank Dr. C. N. Sujata madam and V. Kumar Swami sir and our chief guest for and our resource persons who are spending their valuable time for this program. Thank you all for all of you. Okay, thank you.
Thank you, sir. Thank you for your leadership and guidance. Now it's my pleasure to invite our esteemed chief guest, Dr. Lenin, sir, Director of Engineering JMA Wireless, to deliver his valedictory address.
Yeah, good evening, everybody in the call. Okay, so it's happy to see that your college academic section is conducting this type of programs. Definitely, these kind of programs are going to uh, mold the students in a better way mm, towards getting them good opportunities in their careers, future careers. So MATLAB is one of the great tools uh, with which we can do many things. It has many built-in modules where you can do RF, signal processing, image processing, like multiple things. So it has got very good. It's one of the powerful tools which can be learned and very easy to use. So overall, like other than the MATLAB software itself, the overall knowledge, technical knowledge, which is absorbed here, should be utilized in understanding the subject in a more practical way. Okay, hope this helps the students to achieve greater heights in their future careers. Thank you.
Thank you very much, sir, for your valuable insights and inspiring words. Now I invite our faculty coordinator, Dr. C. N. Sujata ma'am, to address the gathering.
Thank you, Sastra. Respected chief guest, Dr. Lenin, and our Dean Academics, Dr. V. Kumaraswamy, and our HOD, Dr. SPV Subbarao sir, esteemed speakers, faculty members, and dear student participants. A very good evening to one and all. It gives me immense pleasure and satisfaction to conclude this 5-day online workshop on applications of signal processing using MATLAB, organized by EC Department, SNASD. Over the past 5 days, from 27th February till today, this workshop has been a wonderful journey of learning, interaction, and knowledge sharing. We were privileged to host eminent academicians, researchers, and industry experts who enriched us with their valuable insights. The sessions covered a wide spectrum of advanced and practical topics, including basic applications of signal processing, discrimination of one-dimensional and two-dimensional signals, noise cancellation in speech signals, VLSI architectures for image processing applications, signal communication using OFDM and 5G signal processing, image security using cryptography and steganography and watermarking, and finally, signal communication through antenna systems. Each session combines strong theoretical foundations with hands-on MATLAB demonstrations, making the learning expertise experience, interactive and application oriented. I sincerely thank our distinguished resource persons for their time, dedication, and exceptional presentations. Their expertise and clarity have truly inspired our participants to explore research and innovation in signal processing domains. My heartfelt gratitude to our management, principal sir, Dean Academics, Director IQAC, HOD, and faculty members for their continuous support in successfully organizing this event. I also congratulate student coordinators by making this event a great success. I have to congratulate all the participants for their enthusiastic involvement and active interaction throughout the sessions. Your curiosity and engagement made this workshop meaningful and successful. Workshops like these not only enhance technical competence, but also build collaboration between academia and industry. I'm confident that the knowledge gained here will help you in research, higher studies, and professional careers. Let us continue learning, innovating, and contributing to technological advancements in signal processing and communication systems. Thank you all once again for being part of this successful academic event. Wishing you all the very best. Thank you for your time.
Congratulations for all the students for successful completion of the course. I thank Kondaya sir for joining this program, elective program. Thank you, sir. And I wish all the students to complete that MATLAB online certification. That will be great helpful for you here. Okay, that is free of cost. You can do so many online courses that is available on the MATLAB MATLAB website here. Any guidance required, you can contact madam or myself, so that we'll guide. Can get the certification from the MATLAB if you complete that modules. So thank you once again.
Thank you, sir. Thank you, Subbarao sir. Thank you, Kumaraswamy sir, all the students, and today's chief guest and my friend, Dr. Lenin. Special thanks to you for accepting our invitation and engaging the entire session with insightful information.
Dr. Lenin sir, thank you, sir, spending valuable time with us, with our students.
Thank you, sir. No problem.
Thank you all.
Thank you, sir. Thank you all. Dear students, you have to wait for 2 more days to get your certificates. We will be in touch with you through WhatsApp. So once we will receive those certificates, we'll distribute among you. So good night. Happy Holi. Enjoy your day.